Hello everyone. In previous lecture we had discussed all about the compaction and the different factors which affect the compaction and the consolidation and the major difference between the compaction and consolidation. So now let us discuss an important thing. This is optimum moisture content or OMC. So, the OMC of soil is the moisture content at which the maximum dry density or maximum dry unit weight we can achieve after giving a compaction effort. And a maximum dry unit weight have no voids in the soil. So, this is the graph which shows here the moisture content or water content in x-axis and the dry density shows in the y-axis. And here it shows that as the water content increases, the dry density also increases simultaneously up to some extent. After that, water content increases, but dry density decreases. So, this maximum value, this maximum dry density we achieve at a particular water content. This water content is known as what? Optimum moisture content or OMC. So, a compaction curve is plotted between water content x-axis in logarithmic scale and dry density y-axis in natural scale. And as I have told you that the dry density goes on increasing as the water content increases and reaches a maximum value, and then it again decreases. The water content corresponding to maximum density is known as OMC. Next is MDD or maximum dry density. So, the dry density obtained by the compaction of soil at its optimum moisture content is called maximum dry density or MDD. This one. This point is known as MDD, maximum dry density. This point is OMC. That means at that water content we found the density is maximum. This is the MDD. So, let us do a practical or a laboratory test. It is an important test. This is light or standard Proctor's compaction test. So, the standard Proctor test was developed by R. Proctor in 1933 for the construction of earth-filled dams in the state of California. And this test we do to determine or to find out the relation between water content and dry density of soil. And the apparatus which are required as shown in the figure are cylindrical metal mold with a detachable base plate which having the internal diameter 101.6 mm, internal height 116.8 mm and internal volume is this much 915,000 millimeter cube or 0.945 liter. Next is collar of 50 mm effective height, rammer of weight 2.5 kgf or 25 Newton with a height of fall of 304.8 mm. Then next is weighing balance, trowel, IS sieve, mixing tray, graduated cylinder, oven. So, these are the basic apparatus which we use to complete the practical. So, the procedure, let us discuss all about the procedure. Here we have to take 3 kg of dry soil with a lumps pulverized and which are passing through 4.75 mm IS sieve. The quantity of water is to be added in the first trial is decided, which is less for coarse grained soil and more for fine grained soil. Next, mold without base plate and collar we have to weight or we have to measure and we have to note down their weight. This is M1. The inner surface of mold, base plate and collar are greased like this as shown in the figure. We have to grease this. Next, water and soil are thoroughly mixed. Then soil is placed in the mold and compacted in 3 uniform layers with 25 blows in each layer. We have to give 25 blows after keeping each layer. And the blows are maintained uniform and vertical and height of drop is controlled. After each layer, top surface is crushed to maintain integrity between the layers. The height of top layer is so controlled that after compaction, soil slightly produced into collar, like this as shown in the figure. After complete this, we have to cut it, we have to clean the top surface. Next, we have to cut or scrap the excess soil, like this. We have to plane it. Mold and soil are wet, that is M2. Again, we have to take its measurement, that is M2. A representative sample from the middle is kept for the determination of water content. And the procedure is repeated with increasing water content. And the number of trials shall be at least 6. To find a best result, we have to repeat this process at least 6 times. Then after completion of the procedure, we have to calculate it. So dry density equal to, we can put this formula, rho B into 100 divided by 100 plus W, where rho B or bulk density equal to M by V, we know, mass per volume, and M equal to M2 minus M1 by V, where M2 and M1 are mentioned in the procedure. So this is the light compaction test. Next, this is a major thing you have to remember, or you can explain if you know all the datas. So distinction or difference between standard and modified compaction test. So these are the basic difference which you have to keep in mind, and according to this you have to use the instrument or apparatus to complete the modified Proctor test. For example, in a standard Proctor test we use 305 or 305 mm height of drop. We have to maintain this drop, but in case of modified Proctor test you have to drop the rammer from 450 mm height. Then here 25 Newton hammer is used, but modified 45 Newton hammer is used. In standard Proctor test we have to give the 25 blows after keeping each layer of soil. Here also it is same, 25 blows we have to give after each layer of soil. But in standard Proctor test we have to give 3 layer within the mold, but in modified we have to give 5 layer. Then again in standard Proctor test the mold size is 945 ml. Here the mold size also same, 945 ml. The energy required is this much, 605,160 Newton mm per meter cube, but here the energy is 272,600 Newton mm per meter cube. So these are the basic difference between the standard Proctor test and modified Proctor test. So other than this, the procedure is same. So you note down by yourself the total procedure of modified Proctor test. This is also important, both are important for you. Only you have to change these things. Whenever you write the procedure, you have to change these things. Okay? So the question is, describe the heavy or modified compaction test method. So I think now you can write by yourself by using this data. Next, another term, it also an important 2-mark question, zero air void line. So the line showing the dry density as a function of water content for soil containing no air voids is called zero air void line. Or we can explain it like this, a line which shows the water content dry density relation for the compacted soil containing a constant percentage air voids is known as air voids line, and it also known as saturation line as shown in this figure. This is the zero air void line, and it is a basically imaginary line, as it is impossible for us to remove all the entrapped air which are present within the soil mass. And we know, already discussed about that, this is the curve of OMC, this is the MDT point, this is the OMC point, and here this is the zero air boil line. That means it's fully saturated soil. So that it also, or its other name is saturation line. Then this is the formula to calculate the dry density. This is 1 minus Na 0 W by 1 plus Wg. But for zero air boil line, we know Na equal to 0. So that rho d equal to 0 W by 1 plus W into Z. So this is the formula you have to remember to solve some problem. So for this lecture, this much. In next lecture, we will solve some problem based on these formulas. Thank you.